So, in inverter technology, we will be finding different sensor values because we have to measure temperature in different points. In an inverter unit, we will be measuring temperature at points such as the indoor ambient temperature. We found this not only in inverter, but also in conventional. I'll see if we can go down and make a small box to understand it. Indoor ambient temperature. So far we found it in conventional and in inverter. Indoor pipe temperature. As they told you, many overheating temperatures, although it is also subcooling, depending on whether the unit is hot-cold or cold. We'll just call it indoor pipe temperature. In this case, we also have it in conventional and inverter. Outdoor pipe temperature. In this case, in inverter, we will always find it. In conventional, we will find it, but we will put an asterisk. The asterisk will tell us that some will not be found in all conventional units, and I think you know this. In inverter, in addition, we will have outdoor ambient temperature. In this case, we will always find it. Sorry, I made a mistake. We will always find it in inverter. In conventional, we will no longer find it. Finally, compressor discharge temperature. This will not be found in conventional either, and will always be found in inverter. This would be a small box made quickly so that you can visualize and understand what you will find in inverter and conventional. So, when in conventional you will be finding 2 to 3 sensors, in inverter you will find 5. You will always find 5 temperature sensors. All these temperature sensors can have a similar travel value because they are handling temperatures from 4 degrees to 50, 60 approximately within all ambient temperatures. Although, of course, it does not make 60 degrees in many parts of the world, but if they are temperatures close to ambient temperature, then the values of these sensors are usually similar. For example, they usually place 5K or 10K, although some manufacturers vary the values, but approximately they are like this and they are all similar. Now I will explain why in a moment. But the compressor discharge temperature has to have a temperature sensor with a higher value. And that is why in inverter now, additionally, you will find sensors of 38K, 40, 56, or 200K. Yes, in inverter we will find one of the sensors that will have a much higher value. Why does this happen? Don't worry, we'll understand. Let's go back to the graph where we were talking about sensors and their operation. The compressor discharge temperature is a temperature that the equipment measures precisely at the compressor discharge. That is, it has the ability to measure the temperature of the compressor itself, since that sensor is so close to the outlet that the temperature in that pipe is similar or almost equal to that temperature of the compressor itself, and therefore, of the oil and the entire casing. Here we can see it. The outlet of the compressor pipe makes a small turn, and there we already have the temperature sensor. This is the sensor we are talking about. This is going to be measuring temperatures of 80 degrees and more. Why does it have to be more valuable than the rest? Well, because when it is approximately that temperature at 80 degrees Celsius, if we place a sensor of 5K, 15 or 20, it will be in a range of the temperature sensor in a resistance range that will be so low that for the plaquette that measures that temperature, or that value, In reality, it measures it with a small voltage of 5 or 1.2 volts. It will be a value so low, for example, of 100 ohms, that it will not be able to understand it. So, in this place where such high values are measured, what does the manufacturer do? Well, the manufacturer places sensors that are now not 10K, but now 200. Not all of them have 200, some 38, 40, depending on the manufacturer of the plaquette, but let's say they use 200, as is the case with some very well-known brands. So, at the point where it reaches 80, 90 degrees, which is the moment when the plaquette wants to know what temperature the compressor is at, there is a value in ohms of, for example, 5 kilo ohms. It is a value in ohms that the plaquette can understand. And that serves us, the plaquette needs it. So that you understand, in places where high temperatures are measured, and I refer to high temperatures as passing quite ambient temperature, such as 80, 90 to 100 degrees, we are going to place sensors of high ohm value, because the value in ohms is always taken as a reference at 25 degrees. Now, in places where low temperatures are measured, we will have low ohms, because when the temperature drops, the resistance will go up, and it will be easier for the plaquette to understand it, such as, for example, in a freezer of certain brands such as Whirlpool. In these freezers of refrigerators, we find sensors of low resistance, so that when the temperature drops and is found at a point that the plaquette wants to understand it, the value in ohms is appropriate for that electronic circuit to understand it, perhaps 15 to 20 kilo ohms, approximately. I'm going to erase this and we'll continue with our graph. This would be the case of a freezer, and at this point I'm going to find 20 kilo ohms. These electronic plaquettes always want to understand values from 3 to 20 kilo ohms. That is why, if they want to measure temperatures in places with a lot of heat, they have to put higher sensors, so that when they are in the range that matters to us, the value in ohms or travel is the appropriate one. And the same vice versa, if we want to measure very low temperatures, we put low ohms, so that when the temperature we are interested in is reached, we have the appropriate ohmage so that the plaquette can understand it. For that reason, we are going to find a sensor and inverter that will be of more resistance. But you have to learn where they are, you have to see them visually and understand how they work on the electronic board and what errors they present. And we will see that below. Please leave a comment if you have any questions.